Congratulations on finishing the first part of this lesson. You're now ready to move on to part 2, which is about naming ions. You'll notice on your paper that we're going to divide this by nonmetals, type 1 metals, and type 2 metals before we conclude with polyatomic ions. Let's go ahead and start with the nonmetals. We're going to start by looking at the nonmetals. You should know that for nonmetals, we can actually determine their ionic charge just by looking at the periodic table. When we write these chemical formulas, we need to know what types of ions that the elements will form. So with these nonmetals, let's think about what we know about them. If you have your periodic table, you might want to look at that to refresh your memory. Group 15, when we locate it on the periodic table, is found right here. In group 15, these elements have 1, 2, 3, 4, 5 valence electrons. Because they have 5 valence electrons, in order to become stable, they would want to gain 3 electrons. When they gain 3 electrons, this will give them a -3 charge. Remember that the thing they're gaining has a negative charge, an electron. For that reason, I can fill in on my paper that group 15 ions have a -3 charge. If I look at group 16 next on my periodic table, group 16 is the next door neighbor to these guys right here, the group with oxygen. These elements already have 6 valence electrons, so in order to become stable, they need to gain 2 electrons. This will give them a -2 charge. I'm going to fill that in my notes packet. Finally, group 17 is right here. In group 17, there are 7 valence electrons, which means that in order to become stable, they only need to gain 1 electron. That 1 electron that they gain will give them a -1 charge. So I can fill that in. Those charges are things you should have learned in the previous unit, but if you didn't, it's okay, because we just went over them now. These charges will be important as we proceed to writing formulas for compounds formed from these ions. Now it's time to talk about metals. Metals are going to be divided into 2 categories. We're going to start by talking about type 1 metals. Type 1 metals can only ever have one particular charge. For example, group 1 on your periodic table, if we refer back to that, was the first column on the left-hand side. These elements had 1 valence electron. In order to become stable, they would want to lose 1 electron. This gives them a positive charge because they lost something negative. Let me fill that in on my paper, that the charge for group 1 would be a +1. Just to make life complicated, there are a few more type 1 metals. These metals, unfortunately, are ones we're going to have to memorize. The elements to memorize as also being type 1 metals that only have one particular charge are aluminum, zinc, cadmium, and silver. For those 4 elements, they always have one particular charge. Let's start with aluminum. If you look on your periodic table at where aluminum is, you can see that it's right here in the group with 3 valence electrons. Based on that, can you predict what kind of charge it would have? I think it's most likely to have a +3 charge because it has 3 valence electrons, which it can easily lose. Let me fill in a +3 for aluminum. Now we're ready to look at the others. The other 3 elements are zinc, cadmium, and silver. When you look on the periodic table, you find that these elements are all transition metals from the center part of the periodic table. These 3 transition metals can only ever have one particular charge. Notice how aluminum right here had a +3. Notice how zinc is 1 column over. Zinc and cadmium both always have a charge of +2. I can remember that because they're 1 column left of the +3 aluminum. Next comes silver, who's 1 more column to the left, so decrease that number by 1 more, and you find that silver always has a charge of +1. I would recommend that you write these on your periodic table. Let me fill in the numbers here. So type 1 metals are easy because they always have one set charge. They can never be anything else. Type 2 metals, on the other hand, are a little bit more complicated. These metals are actually able to have a variety of charges. They can have more than one ionic charge, which means that they're a little bit more complicated to deal with because we don't necessarily know what charge they will have. In terms of which metals those are, well, they're all the metals that are not type 1. So everybody but group 1, group 2, and the 4 special ones: aluminum, zinc, cadmium, and silver. In order to name these metals, we actually have to use a Roman numeral to show the charge of the ions. This is important because they can have a variety of charges, so we use Roman numerals to indicate which charge they actually have. Do you know what your Roman numerals look like? Maybe you can write these with me in the right-hand margin of your paper. The Roman numeral for 1 looks like a capital I. The Roman numeral for 2 looks like 2 capital I's stuck together. Can you predict 3? Yep, it follows the same pattern. Now we get into funky V's. The letter V in Roman numerals represents a 5. In order to designate 4, which is 1 before 5, we put the 1 in front of the V to show that it's 1 before 5. To show 6, we put 1 after the V to show that it's 1 more than 5. Let's look at an example here. What are the 2 common charges of copper? Well, you probably don't know this, but I've been doing this long enough that I know copper can come in a +1 ion, so that would be Cu with a +1 charge, or it can come as copper with a +2 charge. In order to write a name, I need to designate which of these 2 types I have in my compound. I'm going to use Roman numerals to write their name. For example, the copper that has a +1 charge, I would give the name copper, because remember, metals don't change their names from the periodic table when they become ions. However, I need to show that it has this charge of a +1. To show the +1 charge, I'm going to put a Roman numeral 1 in parentheses right after the word copper. Then I'll add the word ion, because I need to designate that this is an ion, it gained or lost electrons. For the second example, this one's also copper, but because it has a charge of a +2 here, I'm going to use, you guessed it, a Roman numeral 2, also in parentheses, followed by the word ion. So we give the name of the element and then the charge written in parentheses as a Roman numeral, and then the word ion. Let's do a couple practice problems together. In this first example, we are asked to write the symbol for each ion, including the charge. Charge means a positive or negative, so we need to include that. First of all, I see I have iodide. The IDE ending is what we gave to all non-metal ions. So this is telling me I'm looking for a non-metal whose name had iod in it. If you find this on the periodic table, you can find the element iodine. The symbol for iodine is an I, so I'll put a capital I, but I also need to know the charge. Iodine is in group 17, which means it has 7 valence electrons, so it would get a -1 charge. I just want to point out here that sometimes you'll see this written slightly differently. You could also see it written as I1-. It really doesn't matter whether you put the negative sign first or the number first. Either one means the same thing. There's actually one final way we could write this as well, and that's just I with a minus. Without showing any number there, when there's no number shown right here, it's implied to be a positive or -1. So just the minus would mean a -1. This was an example of a non-metal. I could tell that this was a non-metal, that it was an anion, because it ended with IDE. When I look at the next example, I don't see an IDE, which means my naming rules are going to be slightly different. This time, I'm looking for the element mercury. Mercury is one of those annoying elements whose symbol looks nothing like its name. The symbol for mercury is Hg. Remember, the first letter is capital, the second one is lowercase. Because mercury is a transition metal, it can have several different charges. For that reason, we see this Roman numeral 2. The Roman numeral 2 in parentheses is telling me that the mercury had a +2 charge, so I'm going to put that +2 up there. Remember, you could also write that as 2+ if you wanted. Finally, let's look at the phosphide ion. In this case, you see this IDE ending. That should be telling you that you're dealing with a non-metal because it has the IDE ending. PHOSPH. Can you find an element whose name starts with that same combination of letters? You should find phosphorus. Notice that the whole long ending just got dropped in favor of the IDE when it was an ion. The symbol for phosphorus is a P, and then I need to show its charge. On the periodic table, I see that phosphorus is in group 15, so it has 5 valence electrons, and we get a charge of -3. Our next example has us writing names for the ions. So in the last example, we were given a name, we wrote a formula. Now we're given a formula and we have to write a name. Here we have Cu. The first thing you need to do is locate Cu on your periodic table. Cu is the symbol for copper, so I'll start by writing its name. It's a metal, so its ending doesn't have to change. When I look at copper, though, I notice that it is a type 2 metal. It's a transition metal, and it can have a variety of charges. What that means is I need to designate which charge this is here. So if you'll recall, I used the Roman numeral written in parentheses to tell me the charge of the ion. So this was the copper 2 ion. The next example, as I can see, has a negative charge to it. This is an anion. When I look on the periodic table, I find that O is the symbol oxygen, so I start writing oxygen. But then I remember that when I'm dealing with nonmetals, their ending has to change. Instead of oxygen, this becomes the oxide ion. So nonmetals always get this IDE ending on them. Next we have Li. Li is the symbol for lithium, so I'd start by writing its name. It's a metal, so it doesn't get any kind of ending on it. Then the question I ask myself is whether lithium needs a Roman numeral. In this case, I needed a Roman numeral with copper because copper could have several different charges. It was a type 2 metal. Lithium, on the other hand, when I look on the periodic table, is in group 1. Because it's in group 1, the only charge it can ever have is a +1. For that reason, I don't need to specify which charge it is because it's not possible for it to have anything other than a +1. The name here would just be lithium ion with no Roman numeral. Last but not least, we have Pb. Pb, when you find it on your periodic table, is the symbol for lead. Lead is a type 2 metal. It's not in group 1 or group 2, and it's not one of the 4 special ones that we're memorizing, which means that it needs a Roman numeral in its name. To tell the Roman numeral, I look at the charge. It has a +2 charge, so the Roman numeral would be a 2. To complete this name, I need to put the word ion at the end. These polyatomic ions, as a whole unit, carry a charge together. This charge could be positive or negative, although most of our ions are negative, most of our polyatomic ions. It's easy to find these polyatomic ions because they're located on the back of your periodic table. Go ahead and find your periodic table and take a minute to flip over to the back of it. You should find a list there of things you might have noticed but never used before. We're now ready to look at those. Can you find any endings that seem to be very common? Suffixes that multiple ions end with? Hopefully you find that the endings ATE and ITE are very popular endings for polyatomic ions. There are, however, many that don't follow those endings, and some of the important ones are listed right here. Hydroxide is a polyatomic ion that we will use very often, whose formula is OH with a -1 charge. Cyanide, you might have heard of, it's a poison. Its formula is CN with a negative charge. And finally, ammonium is NH4 with a +1 charge. Let's practice naming and writing formulas for our polyatomic ions. These are actually the easiest things to name because all you have to do is find them on the back of your periodic table and the answers are right there. For example, on the back of your periodic table, can you find the sulfate? You should find that the formula for sulfate is SO4 and that sulfate is listed in the -2 column. This means that the whole SO4 together has a -2 charge. Sometimes this is written in parentheses to designate that the whole unit all together has that -2 charge. You can write it either way in this example. Now, can you find ammonium back there? Ammonium is one of the very few positively charged polyatomic ions that we have. Its formula is NH4, and you see that it has a positive charge, or a +1. Remember, we can write the 1, or we don't have to write the 1. Now let's go the other way. Can you find CO3 on the back of your periodic table? You should find this in the column under the -2 charge, and you find that its name is carbonate. Because this is an ion by itself, we're going to include the word ion here. And our last example looks very similar to that one. Do you see how it also has the CO3 part of it? Notice it has the CO3 with the hydrogen added on the front. On the back of your periodic table, you should find that the name for this one is hydrogen carbonate, which makes sense because it was just a hydrogen added to the full carbonate ion. You might also notice that there's a second name given for this one. Sometimes in olden days they used different names that didn't follow all of our rules. The old-fashioned name for this ion was bicarbonate. You'll still see this name sometimes. For example, baking soda is often called sodium bicarbonate, even though we would perhaps more correctly call it sodium hydrogen carbonate. Oops, and I forgot my word ion here. Because it's by itself, it is an ion. All right, you have completed the second lesson.